Welcome to the workshop. The engineer's tri-square is used for measuring and checking 90-degree angles. It consists of a solid stock which is parallel, squared all round, and a steel blade again which is parallel and squared round, and they're set at 90 degrees to each other. Now first of all I'm going to show you how you can check that your tri-square is in fact set at 90 degrees. You will need a board which has a straight edge on it. I've checked the rear edge of this board with a straight edge, and it is perfectly straight. A visual check up against the light source showed no light coming through along its entire length. Now if we take our tri-square, set it with a stock on the left hand side, take a marking knife and make a mark at the edge of the board, and then make a mark at the end of the blade. Now I hope you can see that if I flip this tri-square over, those marks, if it's at 90 degrees, should now line up. And it's easier to show you if I turn the board round the other way. Put our knife into the mark that we made, slide the tri-square up to it, and then we should find that our knife just manages to fall into the knife line we made at the end of the blade. And it does. So that's measured a 90-degree angle like so and like so, which equates to 180 degrees, or the straight edge that we measured on this edge of the board. So that's proved that our tri-square is actually set at 90 degrees. But that's 90 degrees from the inside of the stock to the outside of the blade. What about from the outside of the stock to the outside of the blade? So if we wanted to check the internal angle of two components, perhaps glued together, these two need to be at 90 degrees. How do we check that? Well, first of all we prepare a board squared all round, and we prepare a square end on it. Then we can set that upright on a flat surface, place the stock of our square on the flat surface, and bring those together, and that gap will disappear completely and no light will show through. And that shows us that the outside of our tri-square is at 90 degrees as well. We can also use the squared end of this board to check the internal angle, and again that's at 90 degrees. To prepare the end of this board, we used the inside face of the stock and the outside edge of the blade. We knifed a line all the way round, cut it and planed it to that line, and since we previously demonstrated that the inside edge of the stock to the outside of the blade was at 90 degrees with our check against the straight line, we know that this is a 90-degree angle. So therefore we know when we check it like this and like this that we're checking against 90 degrees. So now we've managed to prove that our tri-square is 90 degrees on the outside edges, 90 degrees on the inside edges, and because we've proved it's 90 degrees from the inside of the stock to the outside of the blade, we've also proved that the stock is parallel across its faces and the blade is parallel. So what is the primary use of a tri-square in our woodwork? Well, it will normally be for checking right angles and for marking right angles at the ends of components. So if we wish to prepare another component like this, we first of all plane a straight edge called a face edge. We plane a flat side at 90 degrees to the face edge called a face side, and then we mark around the component using the stock of the square against the face edge and the face side, and just by using the stock on those two edges we can mark all the way around the component, and I'll demonstrate that now. So here's a board which I prepared a face edge and a face side on, and now we want to cut the end off at 90 degrees so first of all we need to mark using the stock against the face edge. We need to knife a line along here. If we were doing it to get a length, we would first have measured our length with a steel rule and made a mark exactly where we wanted it. So let's say it was there. Now what we do is place our square, stock against the face edge, put the knife into the length mark that we've made, holding the stock tight against the face side, move the tri-square up so the blade comes up against the knife. Lock it in place using a thumb in the middle and a finger to hold the blade down against the work, and then we can mark round with the knife. A few light strokes are better than trying to do one heavy one. Make sure that the edges are well marked, because we use those to transfer the mark around. Now the next one I'm going to mark is the edge opposite to the face edge. I'm going to mark that using the stock against the face side. So we put the stock on there, blade down. We'll place our knife in the end of the knife line that we created on the face side. Move the square in so it touches the knife, lock it in position, and then knife across that edge. Now we'll turn the component back the other way and we'll mark across the face edge. Remembering just to use the face side and face edge as datum references for the stock. Place the stock on the face side, put the knife into the end of the knife line, slide the square up to it, lock it in place, scribe the line. Now we just have the reverse face to mark, and we'll use the face side as the reference for the stock of the square. Put the knife into the mark, slide the square up to it, lock the square in place, and mark the line. And there we are, done. And I hope you can see that we've gone all the way around the component and our knife lines have met precisely on each of the corners. So that's just shown you the basics of a tri-square, how to check its accuracy and how to use it for its most obvious function. I hope you found that interesting. If you did, please like this video, and if you haven't subscribed yet, give that some thought. There'll be plenty more videos coming along which hopefully you'll find of interest.